Today we are doing adding and subtracting of rational expressions. Now I've got 5 steps lined out. Understand that not all 5 steps of these will be necessary every time, but we want to check them every time to make sure we're not missing anything. Step 1 is to find your restrictions. We are always, whether we are multiplying and dividing or adding and subtracting, we always want to find our restrictions first. Now notice that it does say factor first if necessary. So if you've got a GCF or you have a trinomial, go ahead and factor before we do the restrictions. It'll just make life easier. Okay, the second thing we want to do is find your least common denominator. Again, if they're already the same, no work to be done. Just identify the least common denominator. If they are not the same, then we have to figure that out. If we have to actually create a least common denominator, step 3 is find your new numerators. Remember that if we change the denominator, we have to change the numerator by the same amount. So make sure you don't forget that step. Step 4 is adding and subtracting the numerators. Remember, when we add and subtract fractions, we only combine the numerators because our denominators are common. And then step 5, if there's anything at the very end that can be simplified from top to bottom, from numerator to denominator, we want to go ahead and do that. So let's go ahead and do our first example. Step 1, we want to find our restrictions. Well, both of the denominators are 8v, so I'm going to come over here. 8v equals 0, and I'm going to solve for v. Divide by 8, divide by 8. V equals 0 divided by 8 is 0, so V cannot equal 0. Now, since the U is not in the denominator, we are not going to have a restriction on U, because remember, the restrictions are about not allowing the denominator to be 0. Alright, so we've got our restriction. Step 2, find your least common denominator. Well, luckily, both of the denominators are the exact same, so we have a common denominator. We don't have to do anything else with this. Since we didn't have to change our denominators, step 3, we don't have to change our numerators. So we are ready to go straight to step 4 and add or subtract the numerators. Now, what I want you to realize is what we're doing here is we're just combining like terms. We're adding u minus v plus 6u minus 3v. Okay, so u plus 6u is 7u, and negative v, we have to take the signs in front of it, minus 3v is negative 4v, and our common denominator is 8v. Now, at this point, the only way I can reduce anything is if each number has, or all 3 numbers have a common factor. They don't. So this is my final answer with that restriction. Okay? All right, let's go ahead and go to the second example. So here's our second example, and I need to find my restriction first. So I've got 6m cubed times n. This cannot equal 0. Well, we can solve for each variable and divide and all that good stuff, but the reality is, since all 3 of these things are being multiplied together, m can't equal 0 and n can't equal 0. Because if one of those is 0, when we multiply all 3 of those things together, our answer is going to be 0. So we're going to keep this a little bit simple. So here are my 2 restrictions. Then I'm going to notice, okay, my denominators are the same already, so I don't have to do anything there. Since I don't have to do anything with my denominators, step 3 is taken care of. I don't have to do anything with my numerators. I am going to write this one a little bit differently as I work it out, though. I'm going to go ahead and write this problem with one denominator. Since they're common, I can do that. Then I'm going to write my m minus 3n minus, and I'm going to put parentheses, m plus 3n. Why am I doing this? Because I want to be sure that you recognize this negative, or this minus sign, is going to have to be distributed to each one of those. If you worry about those sign issues, write your problems like this every time. So I am going to go ahead, and I've got m minus m gives me 0. They cancel each other out. And then I have negative 3n minus a positive 3n. Negative 3n minus 3n is negative 6n over 6m cubed n. Now, step 5 is look to see if you can simplify anything. Well, we can. Negative 6 divided by 6 is a negative 1, and n will cancel with the n, so it is left over m cubed. Okay, so this is my simplified answer, and these are my restrictions. So that had more of the 5 steps in it completed. Okay, let's look at another example. Okay, here's our third example. So we're going to find our restrictions first. Well, I've got an x minus 1 and a 4. Well, I'm quickly going to sit here and show you 4 equals 0 is not a true statement, so we don't have to worry about that. It's just untrue. So we're going to focus on x minus 1 equals 0, plus 1, x equals positive 1. So that's what we can't have for x. So 1 is our restriction. Okay. Now, we need to find our least common denominator. Well, what I'm noticing here is that these two things are not the same. Okay, they don't share anything. So remember on the previous video I told you what we're going to do in that situation is we are going to just multiply those two things together. 4 times x minus 1. Now it does not matter whether you put the 4 in front or behind, but in algebra we always tend to put the number in the front. So I'm just writing it in our normal algebraic way. All right, so sorry about that, I erased part of my numbers. Okay, so what I'm going to do is I'm going to come down here and I am going to write my common denominator under both fractions of my problem. So I just brought everything down, okay? Now, I need to, since I multiplied this by 4 to get this, I also need to multiply the top by 4, because remember we can't change the value of it, so whatever we do to the bottom we have to do to the top. 4 times 6 becomes 24. This is step 3 where we are adjusting our numerator to our denominator. Okay. Now, in this denominator, I multiplied the bottom by x minus 1 to get my least common denominator. So I am going to multiply the top by x minus 1 also. This means we're going to have to distribute. So 5x times x is 5x squared, and 5x times negative 1 is negative 5x. Okay, let me put these in different colors. I multiplied the numerator and the denominator by 4 to get this. And over here, I multiplied the top and the bottom by x minus 1 to get this. Okay? Now, I'm going to go on and add and subtract. So remember what I did above. Because I've got the minus, I'm going to go ahead and, write the problem correctly. Write my denominator one time and do 24 minus 5x squared minus 5x. So I do not have anything to combine the 24 with, so it's just 24. And then I'm going to distribute my negative here and here. Now what I'm seeing is I'm going to have a trinomial, so you could write it as 24 minus 5x squared plus 5x over 4 times x minus 1. But what I'm going to do is I'm going to rearrange my trinomial in standard form. So negative 5x squared plus 5x plus 24, because it's a positive 24, over 4 times x minus 1. Okay, so here I have my answer, here I have my LCD, and here I have my restrictions. Now, if I could factor this nicely and cancel an x minus 1 out, or even a 4 out, I would. I'm pretty sure I cannot factor that to get an x minus 1 as a factor, so we're going to stop there. All right, let's do another one. Okay, so I have 3 over x plus 7 plus 4 over x minus 8. First thing I'm going to do is find my restrictions. So x plus 7 equals 0, starting with this one. Subtract 7, x equals negative 7, so x can't equal 7. And now I've got the x minus 8. X minus 8 equals 0. Add 8 to both sides. X equals positive 8. So it can't equal negative 7 or positive 8 because those two numbers, if we plug them in, would make our denominator 0. Okay, my least common denominator. Well, I've got x plus 7 and I've got x minus 8. They don't have anything in common. They are not the same thing. So I am just going to multiply them together. Oops. Okay. So let's go ahead and start working the problem. I know to get a common denominator of x plus 7 times x minus 8. Here, I need to multiply x minus 8 to the top and the bottom. So I'm going to rearrange where I write that. Sorry. I'm going to write it over here. So you can see we need to distribute that 3. Now, this is step 3 where I am adjusting my numerator because I had to adjust my denominator. So 3 times x is 3x minus 24. Now, over here, I had to multiply the denominator by x plus 7, so I also need to multiply the top by x plus 7. Again, I'm going to distribute. I get 4x plus 28. Now, if you want, we can go ahead and write this like we have been. We're going to end up with one denominator. We've got 3x minus 24 plus 4x. Now, you can put this in parentheses at this point, but since this is a positive, we really don't need to. It's not going to change any signs. So I've got 3x plus 4x is 7x. And then I've got negative 24 plus 28. That's going to leave me with a positive 4. X plus 7, x minus 8 on bottom. I do not have a GCF on the numerator, so I do not have anything else that I can simplify. My answer, my LCD, and my 2 restrictions. Okay, we are going to do one more, and then I will leave you to your practice. Okay, first thing we want to do are restrictions. I've got an n plus 5. I've got a 2n plus 6. I see a GCF in there of 2, so let's factor that out first. 2n divided by 2 is n, 6 divided by 2 is 3. Alright, so let's go over. We've got n plus 5 equals 0, subtract 5, n cannot equal negative 5, and then 2 equals 0 isn't a true statement, so we're ignoring that one. And then n plus 3 equals 0, minus 3 from both sides, and we get n equals negative 3. So negative 3 would make it 0 also. So we've got our two restrictions. All right, so then we need to look for our least common denominator. Now I've got an n plus 5, a 2, and an n plus 3. All of them are different, so that means I am going to have 2 times n plus 3 times n plus 5. It is absolutely fine if these two parentheses are switched. That's not going to be a problem because it's multiplication. So we've done step 1, our restrictions. Step 2, found our least common denominator, and I did factor because that was necessary. So now I am going to write my least common denominator . 2 times n plus 3 times n plus 5, and over here 2 times n plus 3 times n plus 5. Now, step 3 is to adjust the numerators. So down here, I had to multiply by 2 and n plus 3, so I need to do that here also. Now what I'm noticing is 2 times 5 is 10 times n plus 3. And over here, I had to multiply the bottom by n plus 5 to get my, let's put that down here. N plus 5, so I need to multiply the top by n plus 5. 4n times n plus 5. Okay, now to be able to add, I'm going to go ahead and distribute these on both sides. So I'm going to write my denominator once, n plus 3, n plus 5, and I get 10n plus 30. Since this is a positive, I don't really need to distribute the plus 3 because it's not going to change anything. So 4n times n is 4n squared, and 4n plus times positive 5 is 20n. Now I am going to combine like terms. I have a 10n and a 20n, which is 30n. I'm going to go ahead and put my 4n squared in the front, just because I'm putting it in standard form as we go. And then a plus 30 at the end. And this is all over 2 times n plus 3 and n plus 5. Now, I went ahead before I started this example for you, checked to see if our trinomial could be factored, and it cannot. So there's nothing to cancel from top to bottom. So I'm going to leave it in that form. So again, my restrictions were n cannot equal negative 3 and n cannot equal negative 5. So we've got our least common denominator, our restrictions, and our answer. All right, we're going to stop with that one and let you get some practice. Email with questions.